Hey students, in this lesson we're going to go through volumes of prisms. That is section 10.4, and our learning target is I can find the volume of a prism. So the volume of a three-dimensional figure is the measure of the amount of space that it occupies. Volume is measured in cubic units, or another way that we say cubic units would be units cubed, so to the power of 3. So in the previous sections, we found surface area, so that's measuring the area of the outside of a figure, and then volume is the space that the figure occupies itself. So it's like filling up the inside of something. So rather than finding the area, the outside of something, we're seeing how much space does this thing take up altogether? How much stuff would fit inside of it? You could think about when you hear that cubic units or units cubed, imagine that you have a box and you're filling it up with tiny little cubes and you're seeing how many fit inside. That would be an example of volume, seeing the space that three-dimensional figure occupies, how much stuff you can fill it up with. So for volume of prism, the volume, capital V, of a prism is the product, remember product means multiplication, of the area of the base and the height of the prism. So here's two examples of prisms. There are more. These are not the only two prisms that exist. Remember, whatever shape the bases are in a prism, that defines what type of prism it's going to be, whether it's rectangular, triangular, etc. So in this prism here, the bases are rectangles. So we find the area of the base and then we multiply it by the height. Same thing here. We find the base. In this case, again, the bases are rectangles, and then we multiply it by the height. Notice here that it's showing you even when our prism is slanted, the height should always be going straight up and down. Just like when you're dealing with triangles and the height of a triangle should be going straight up and down, the height of a prism should still be going straight up and down, any height in general. And so here's that formula. Volume equals B times H, area of base times height. You'll notice this is a capital B versus a lowercase, and that's because it does not stand for base, because base is just the base length of something, right? The base length of a rectangle or triangle. Capital B stands for area of the base, so the actual area of that shape that is the base. So let's go ahead and try example 1, find the volume of the prism. So I'm going to take my formula, volume equals area of base times height. First, I need to identify what the base is. So the base is going to be this rectangle right here. Depending on the way they draw this, the base could be a different rectangle too. So rectangular prisms are kind of a little bit different because any of those faces could really be the base. It just depends on how we draw it. But whichever shape you choose to be the base, doesn't matter. The height is then going to be however tall it is from one base to the next. So those two bases, a prism has two bases, those are going to be those opposite, identical, parallel faces, and then the height is going to be going in between them. So the area of the base here, because it's a rectangle, I'm going to do base times height, so 6 times 8, and I get 48. So the area of the base is 48, and then I'm going to multiply it by the height, 15, and I get 720. And then don't forget to label it, again, because it's volume, it's going to be units cubed, in this case, yards cubed. And then example 2, so this is a triangular prism, and this one is a little bit more challenging, and that's because a lot of people are going to automatically say, oh, this rectangle on the bottom, that is the base. That is actually not the base. The base is not necessarily always on the bottom. Sometimes we draw things in a way so that the base is not on the bottom, and in this case, that's actually what happens. In this prism, the base is this triangle right here. And here's how I know that. Because in a prism, there are two bases, and they must be opposite from one another, and they must be identical, and they must be parallel. The only two shapes or faces here that are across from each other, that are the exact same shape, that would never ever touch, are those two triangles. And so those two triangles, those are the bases. Meaning when I find the area of the base, I'm going to find the area of that triangle right there. Imagine redrawing this and putting that triangle flat on the floor, and there would be another triangle right up above it. That means that the height is going to be this 4 inches here. Again, I know it's laying sideways, and we might think, I thought height has to go straight up and down. But again, if you imagine that they twist this prism so that that triangle is sitting flat on the ground and there's another one up above it, this 4-inch side is the one that's showing us how tall it is from base to base. And let's actually add a little note here. In a triangular prism, forgot an R, triangular prism, the bases are triangles. That is why it's called a triangular prism. because a prism is named after whatever shape the base is. But just as a little note to help you out, when you're finding the volume of a triangular prism, the base is actually the triangle, because sometimes they don't draw that triangle actually on the bottom. Oftentimes it is drawn actually this way where it's kind of facing you. So that's just a little kind of tricky part there. So I'm going to find the area of the base. It's a triangle, so I'm going to do base times height divided by 2. The base of this triangle is 5.5, and its height is 2. So 5.5 times 2 divided by 2, that would be 5.5. And I'm going to multiply that by the height. Again, that's 4 because that's the measurement going from base to base, triangle to triangle. When I do that, I get 22. Don't forget to label it. In this case, I'm using inches cubed. My units cubed. So the volume of any prism is the area of its base multiplied by its height. And remember, a prism has two bases. Those are the two faces, sides, shapes that are opposite from one another. They're across from one another. They are identical. They're the exact same shape, and they are parallel to each other. So the first thing you always want to do when you look at your prism is decide, okay, which shape here, which face has a pair, has one that is the same as it, that is across from it, that is equal to it, because that's your base. That's what you're going to find the area of to represent capital B. And then that height is whatever's going between those two bases.